Hello and welcome to 813 Simple and Compound Interest here with Integrated Math 1. We'll be on page 442 in your text to follow along. So today you will apply your understanding of exponential functions to solve problems with money and interest. So remember that thing called simple interest? We'll explore that today, and we'll also learn about a little thing called compound interest. All right, so we'll start with the saving for college table. I want to turn your attention to the far right side of the screen. We've got a table here, and it looks like the amount of money that you're investing is growing. What's it growing by? Let's remember our rebound ratio skills, that multiplier. Take one amount divided by the previous, and we can find a multiplier. Or be on the lookout for something increasing at a linear rate as well, which means adding by the same amount. Those are two types of patterns we're used to searching out. So let's take a look at this problem. Suppose you have $1,000 to invest and you know of two investment options that offer an 8% annual interest rate. But you can invest in bonds, which pay 8% simple interest, or put your money in a credit union, which pays 8% compound interest. Will the option you choose make a difference in the amount of money you earn? Part A, if you invest in bonds, your $1,000 would grow as shown in the table at the right. How does the amount of money grow with simple interest? Well, let's take a look. How is the money increasing over time here? It looks like we are adding by $80 each time. We just keep adding that $80, and that gives us the next amount of money after another year has gone by. So that's a linear trait, because if you recall simple interest, that I equals PRT equation, that's just multiplying by the same amount, right? Or adding by the same amount in this table. Linear has a slope, right? That's what's multiplying times X, but it really means increasing at the same rate or decreasing at the same rate. So, part B, by what percent would your balance have increased at the end of the fourth year? The key note here is by what percent. So that means we are going to figure out what that value is in the fourth year. And then we're going to take a look at our original investment of $1,000 and compare it to that fourth year. So let's start by taking this table and continuing our trend. 1,240 plus 80 is going to take us to 1,320. All right. So remember that rebound ratio. I keep referring to that. That's going to help us find our multiplier here, our percent increase. So let's take that 1,320 and let's go ahead and divide that by the original $1,000 investment. So 1,320, grab your calculators. Divided by 1,000. That's going to give you a value of 1.32. So what does that mean? It means that if you multiply that 1,000 by 1.32, you'd get 1,320, or you've gone up 32% increase from your original investment of 1,000. That's a huge increase. So that gives us a quick glimpse at simple interest, adding by the same amount, but also a sneak peek at, hey, remember, we could also grow money by multiplying. Let's take a look at that. So in part C of this problem, we are now studying compound interest. Instead, if you invest your $1,000 in the credit union at 8% compound interest, that is compounded once a year. Its value would grow as shown in the table at the right. Let's explore how it's growing, and let's see if we can't figure out what this compound interest means here and why there is $1,166.40 in our account at the end of that second year. So zoom in on the table here, and let's take a moment and pause and try and figure out the pattern here. Pause this video and take a look. What's that multiplier? Okay, if you've had a chance to take a look at this, let's go ahead and grab any one of these two values and let's find the multiplier. So how about the first two? We started with 1,000 and that turned into 1,080, right? Okay. Well, remember, they told us up here something's happening at 8%. So let's see. Is that what's happening here? 1,080 divided by 1,000? Well, that's 1.08. What that means is your money is increasing by 8%. Just want to make a quick side note. If your money was going down, you would be decreasing by 8%, and your multiplier would be 100% minus that 8%, or 92.92. So if you're increasing, you're going up from 100. If you're decreasing, you're going down from 100%. Okay, let's go ahead and take a look at that missing year number 4. Now that we know our multiplier, and they told us to be fair at the start, let's go ahead and multiply that by 0.08, but don't forget that 1 out front or you would get much smaller than what you began with. So we've got times 1.08 times 1.08. That's how we get from one value to the next. So let's take 1259.71 times 1.08, giving us 1,360, about 49 cents after that. So that's how much money we would expect to have in our account after 4 years. How did that compare to the simple interest? Remember that one? Let's go back up here. You only had 1320 there after 4 years. After 4 years here, you got 1360. And it's going to keep multiplying by 1.08 instead of just adding by 80 each time. So compound interest happens to the previous amount, an amount that is added up to your original investment and all that stuff on top, all that interest. So if we try and wrap our minds around what is compound interest, how is it calculated? You are multiplying or increasing in value, not only by your original investment, but by that plus the interest on top of that. So you're earning interest on that principal and the previous interest. Let's pause this video and take a moment to write down some of these buzzwords that you see here in this table. In fact, just write down this whole table, especially that equation right there. Super important. That is your equation for compound interest right there. That's going to give you your amount based on your initial investment, which we call the principal. And then you've got R for rate as a percent, right? As a decimal. That decimal of 8% is 0.08. And this divided by N, this N right here. So N is something we take a look at in a problem when they tell us how often is something compounding. These are all values of N right here in this column based off of what these words are. Annually means once a year. So that's not going to change your rate. Dividing by 1 doesn't change the value. Semi-annually, though, is twice a year. So that would divide your rate by 2 here in the equation and also give you a multiplier of 2 right there. Quarterly, 4 times. Monthly, 12 times. Weekly, 52 times. Daily, 365 times. Whatever it may be, that's your N value. The number of times that compounding is taking place. So take a moment, pause this video, jot this down, and resume when you're ready to move forward. Okay, now that you have the notes necessary and a couple examples under your belt, let's try some individual work here. In 8-37, you're looking at a problem where interest is compounded quarterly. So what are the key things you need from any problem? If you go back to the previous notes you just took down, you need that starting amount, also referred to as your principal, you need the rate that you're getting written as a decimal. You need to know the number of times things are being compounded. Those are the key pieces you need. So pause the video and try 8-37 on your own, and then resume it, and we'll go over it together. Okay. Hopefully by now you've had some time to take a look at 8-37. If not, pause it and finish up. And then let's take a look. All right, so we've got something going on here, 8%. Our eyes are going right to that. One example is a money market account that offers 8% annual interest, but it's compounded quarterly. And that tells us that that means 4 times a year right there. So if we were to write down all those key things, we know that we're getting a rate of 8%, which is 0.08. The number of times it's being compounded is quarterly, which means 4 times. So those are some of the key pieces we know right there. In part A, they tell us that we have a $1,000 investment. That's our principal. So that's how much we start with, or like your y-intercept. Okay, so y is the money we get. X is what's happening over time. So we need to come up with an equation here. So let's take a look at what you're able to come up with for 837 part A. All right, so looks like we've got our money, right? Our principal. And now we're going to start with 100% of our value. But what we ended up doing was taking that 8% and dividing it by 4. So that's going to turn into 2% here in just a second. One interesting note is the next part is usually n times t, which would give us 4t. But they're determining that your exponent x is the number of quarters. So instead of 4t or 4x here, we're just going to have x because x is not representing time in years. X is representing quarters. So our equation for part A, again, our final equation will be 1,000 times 1.02 to the x. Okay. Part B, use this model to calculate the value of your investment after 4 years. So all we're going to do is take that 4 years, then we're going to plug it in into our equation. All right, so B, we've got our initial investment, we've got our multiplier, and now the key here is that during the time that 4 years passes by, there's 4 quarters in each year. So 4 quarters times 4 years means this is going to compound 16 times. And that's why I'd really rather see like a 4t in here where t represents years, because that might illustrate better to you all where that 16 came from. 4 quarters in 1 year and 4 years have passed by. So that's 16 quarters. So when you enter that in your calculator right there, you're going to get a money value of $1,372.79 right there. And how does that compare with your investment in problem 8-32? Well, you remember that one? 4 years passing by? Let's take a look. So that was 1,360, and we just cashed in at 1,372. So seems like compounding quarterly is earning us more money than compounding here annually, which is once a year. Earning interest on your interest and principal one time every year, or earning interest on that principal and interest 4 times a year. Which would you rather have? Okay, That is going to conclude our lesson on simple interest and compound interest, which is our focus today. Remember, compound interest is just exponential growth. It's your money earning money on top of your interest in principal or your initial investment. So, target check. Can you apply your understanding of exponential problems to solve money problems with compound interest? Next steps, complete the homework practice, homework number 80. I hope this lesson helped. You can always go back and review it. It's linked to your Schoology page and homework calendar. Have a great day.